Okay, so how do we graph this? Remember, the basic is that you use numbers for x. So the most basic way is you select x and then just find the y. Now, x is inside the radical sign, so you cannot have negative numbers. So the smallest that you can have is 0, then you go 1. Usually you use the next number to 1, and that is 2. But if I use 2 on the square root, that will give me a decimal number. Okay, a decimal that is not a whole number. So the next number that I can use is 4. Because the square root of 4 is 2, I can find it. Only for convenience. Okay, you can skip 2 and 3. So if I put the 0 here, square root of 0 minus 1, the value is at negative 1. Because square root of 0 is 0, so 0 minus 1 is negative 1. Now if I place the 1 on x, so suppose I want the x equal to 1, what will be the value of the function? If I will place the 1 on x, so if I will place the 1 here,
0.
so 1, square root of 1 is 1, minus 1 is 0. So this will become 0. If I will place the 4, so square root of 4
2.
is 2, 2 minus 1
1.
is 1. So I have now at least 3 points to help me graphing the function. Okay. So to graph, I'll create the xy plane. 0 is actually the smallest x that you can have. So that's a good starting point. So at 0x, the y is at negative 1. So the first point is at negative 1. When x is at 1, the y is at 0. So that means it's just on the x equals 1. When x is 4, so I have to add 2, 3, 4. The y value is 1. Remember, the square root, the basic function y equal the square root of x, the graph should look like this. It's a half parabola facing to the right. If you look at the points that we obtained from the square root of x minus 1, you can actually see that the graph will follow a path passing through the 3 points. Okay, so that's how you graph this one. But remember, I told you a faster way of doing this. So suppose I'm not interested in using a table of values. The easiest way to graph it is that you have to recognize what is the graph of the square root of x, which I already mentioned a while ago. So it should be at 1, 1. Then when you connect the two, that's the graph. Follow?
Mm-hmm.
Now, if you look at the given, it's minus 1 after the square root. Remember the effect of adding and subtracting a number? If it's outside the square root, what will be the effect on the graph? A minus 1 will make go down. Which one will go down? It's the graph of the y equals the square root of x. The graph of this will go down by 1 unit. We have 2 points that we can use. So if I have to move them down, so the blue point will be located here, 1 unit down. At 1, initially, it will move down by 1, so it will be at 0. And then you can just connect the 2 points. That's the graph of the square root of x minus 1. Now, what I want you to be careful of is that when we have a new function, f of x is equal to the square root of x minus 1. How is this different to the square root of x and then minus 1?
The f of x,
So let's call this A, let's call this B. So let's describe B.
in B it's a whole number.
Mm-hmm.
So it's really a square root of x minus 1.
What will be the movement? How do you describe the movement
Um,
from the square root of x graph? How will it move?
it would go left or right.
But in this case,
So it would
what
be
direction?
right.
Right, a minus on the x will move it to the right.
Yes.
Okay, but outside the x, if there's a parenthesis, there's a square root, there's an absolute value, it's always up or down. Okay, so minus 1, moving 1 unit to the right. So going back to the basic graph, so this is the basic graph. So this is the graph of the absolute, the radical sine x, or the square root of x. If I have to move it 1 unit to the right, it will start from this point. So 1 unit to the right. The second point will move 1 unit to the right. So when you connect those 2 points, you will be creating the graph of the square root of x minus 1. Can you follow? Okay. Now, another case, I noticed that you're not sure. So let's have a new function. Suppose I want to graph 1 over x. What's the basic graph of 1 over x? It's the mirror thing. Like,
Yes, sir. The
you have this,
it will be on the
like this, right, on the first quadrant, and then on the third quadrant. This point here is 1, 1. This point here is negative 1, negative 1. Okay, that's the exact location. So again, this is 1, 1. This point is negative 1, negative 1. Now, this will be the variations. From the basic 1 over x, the function can change into something like 1 over x minus 1. So from the graph of 1 over x, how will you describe the graph of 1 over x minus 1? Yes.
They both go down by 1.
They will both go down by 1.
The y-axis.
The y-axis. Okay, I'll give you another function. And then you might want to rethink of your answer. 1 over x minus 1.
Oh, sir, they go to the left.
Which one?
The x.
Okay, let's call this A. Let's call this B. Describe A.
A is gonna move to the left.
Left. Richard, what can you say? A.
if it would go yes to the
To the right.
sir,
Y to the right.
because it's negative.
Minus.
Yes.
Okay, on the x. So 1 to the right. Now, the letter B, the minus 1 is after the 1 over x. The minus 1 is after the 1 over x. How will you describe the movement?
Go up or down. So in this, it would go down.
Go down by 1. Okay? I want you to see the difference because these two are not the same.
Yes.
This is within the x. You see, x minus 1. This is outside. You can think of it as outside of x. 1 over x and then minus 1. So, in letter A, I'll create a red graph. That's for letter A. 1 unit to the right means this point will move 1 unit to the right. This point will move 1 unit to the right. So if you're moving everything 1 unit to the right, the axis, this axis will be moving by 1 unit. So you can create a dotted line to represent the movement. So that will be your guide when you graph the 1 over x minus 1. You cannot pass through the dotted line. On the second graph, so you should pass through the point, but you cannot go through or pass through the dotted line. Okay? Is that clear? Now, for the other function, 1 over x minus 1, it will go down by 1 unit. So from the original graph, so if we have the original graph like this, so say this is the point, this is the point, the 1 over x minus 1, 1 over x and then minus 1, will have, so this point going down by 1, this point going down by 1. Now the x-axis will be moved also, as if we are moving the x-axis. So from 0, it will go down by 1. So you have to create a dotted line so that you will know where the boundary is. And then finally, just connect or just pass through the points indicated on the xy plane. That's the graph of 1 over x minus 1. Clear now? Okay, what about the others? You understand this? These are the two most crucial functions in terms of graphing. The other functions, they're easy to plot or graph. Okay, so that's it.